Imagine a team of unmanned robots finds and collects plastic and other debris from the seafloor autonomously. They use artificial intelligence software that can detect litter through sonar and camera images, which is then picked up by a gripper. At this moment, between 26 and 66 million tons of waste pollutes the sea, 94% of which is on the seafloor. Some litter is already being removed, but mostly from the surface. Plastic from below the surface is now only removed on a small scale by divers. This is expensive and risky for the divers. Solving this problem requires a scalable and autonomous solution. A team of researchers from several European countries is building autonomous robots to collect debris from the seafloor. Bart de Schutter, professor at the Delft Center for Systems and Control, coordinates the project SeaClear.
On the screen you see our setup. We have a surface vessel, which is the base station, and there are two underwater robots. On the right you see a small underwater robot that is the so-called observation robot. That robot scans the seabed with a camera and with sonar, and its aim is to collect information, so to find out where there are pieces of litter, and to also distinguish the pieces of litter from, let's say, sea life, like fish or seaweed. So for this we use advanced algorithms to classify litter. Once the underwater observation robot has detected a piece of litter, it sends the information to the other vehicle, the one on the left, which is equipped with a gripper. So that underwater robot can go to the piece of trash and with a gripper lift it from the seabed and then transfer it to a collection basket. And now that the gripper is finished, we can start to do like real tests to collect trash from the bottom of the seabed. So it's an important milestone in the development of the SeaClear project.
The challenging part of the gripper design is that it should be able to grasp a wide variety of objects, like bottles or plastic bags. At the same time, it cannot harm marine life. Besides the coordination and integration of the research, the TU Delft also contributes to the image recognition software.
So the idea is that with the underwater video data, we detect whether there is a piece of litter on the seabed, and next we classify the piece of litter. The observation underwater robot is equipped with both sonar and video, and in some places the video can be used in an excellent way. For example, in the test site in Dubrovnik, we have very clear view underwater, so we can really use the camera. But if we move to Hamburg, there is a lot of sand and mud in the water, so the range of the camera is very limited, and there we have to use the sonar. So one of the ideas that we are going to investigate is how can we transfer labeled data for video through sensor fusion into labeled data for sonar.
SeaClear aims to build and test a prototype system soon. In the future, whole fleets of robots will clear the coastal waters without harming marine life in the process.